Okay, so let's explain the problem number 3 on the fall 2014 Physics 2048 exam. So, the problem reads, a motorist drives along a straight road at a constant speed of 80 meters per second. At t equals 0, she passes a parked motorcycle police officer, and the officer takes off after her with an acceleration at equals bt, where b is a constant and t is the time. In other words, the acceleration varies linearly with time. If the officer maintains this rate of acceleration, what is the speed of the police officer when he reaches the motorist in meters per second? So, let's first think conceptually about what this means. This means that the distance traveled by the officer and the woman, the motorist, have to be equal. And when that happens, we can look at the what the velocity and the acceleration, what those are at that given time, at that given moment, and figure out. So let's use our kinematic, and we're going to use d equals vit plus 1/2 at squared. And what we're going to do after that is we're going to create two different ones. The first one, d1, is going to represent the woman motorist. So d1 equals vit plus 1/2 at. We know straight off the bat that the velocity is constant. We're told by the problem that means the acceleration is 0. So that means that it's just vit, and we are told what vi is, right? The initial velocity of the woman is 80 meters per second. So vit equals 80t, and that's equal to d1. Now d2, on d2 we have that the velocity, initial velocity of the police officer is 0 because she was not moving at the beginning of this problem. Then we're told what her acceleration is. We're told that her acceleration is not constant. It's actually dependent on t. So that means the acceleration is not constant, it's changing. So that means that we have to look a little bit about what this really means. This means the integral of at. So if a is not constant, that means that if a equals bt, then the integral of bt t, or in other words, the integral of bt squared, and that's equal to 1/3 bt cubed. So that means that d2 is actually equal to 1/3 bt cubed. So now let's set those equal to each other. d1 equals d2, and we know that d1 is equal to 80t, and we know that d2 is equal to 1/3 bt cubed. Now, if we multiply 3 on both sides, we get 240t equals bt cubed. Now, we can cancel out 1t, and then we get 240 bt squared. And here's the interesting thing. 240 over t equals bt. In other words, that means that when we plug in a value for t into the equation for acceleration, we're actually getting the velocity, because we're finding out exactly how fast it is moving when we plug in a value for t on a non-constant acceleration. So that means that 240 over t, which we know these are both represent displacements, ultimately, because these are d1 and d2, that means that 240 over t, that displacement, which is expressed in other words as the velocity, 240 over t is the velocity, is equal to bt, which means that this is actually our final answer. 240 meters per second displacement over time equals bt.